Hello and welcome everyone. In this video I would like to show you how the MICADO framework is working, how you can create your infrastructure and how it will be automatically scaled up and down on demand. For the target cloud I choose Cloud Sigma, where we have at the moment 2 nodes. One of the virtual machines runs Octopus, which is a cloud orchestrator, which will help us to create the basic infrastructure, and the other one is mainly just used to store the configuration files and which will call the Octopus through the Octopus API to build up our infrastructure. First, there are a few things that we can modify in the infrastructure descriptor file. Everything is modified here, nothing else you have to do. You have to specify in which ranges you would like to scale your application node types, your node types. We have 2 node types which we can scale. One of them is the load balancer node type and the other one is the application node type. The load balancing node type will share the incoming load from the users, while the application node type will run your application that you can interchange. We choose 1 and 5 and 1 and 10 for the 2 node type. The other 2 things or 3 things that we have to change is the Octopus REST API IP address, and which can be different in your case. The other one is the port address on which the Octopus API is listening. And the last thing that you have to modify is the application port on which your application will be reachable. In our example application, which is a data avenue application, we choose it to be the 8080 port. When we are ready, we can start creating our infrastructure. We have to log inside the virtual machine, go to the configuration files, and with a simple command we can send it to Octopus. If you see the output of the command, you get back an infrastructure ID from Octopus, which means your infrastructure will get this infrastructure ID later. For building a few virtual machines, we have to wait a few minutes, so let's skip it. Now you can see the virtual machines that have been built up. We can see a few. One of them is the load balancer, the other one is the application node, which in our application specific case is called data avenue node. We have a console node which where the console agent is running. Console is a node discovery agent. And the other one is Prometheus. On the Prometheus node, the monitoring subsystem is running. Let's go a little bit deeply into this infrastructure. Our example application will help us to send files from one data store to another one. In our case, it will be an SQL database where we will send them. And as you can see, the users will access the applications through the load balancers, which will proxy or request thanks to HR proxy to one of the application nodes in the background. We have the monitoring and service discovery nodes, which is console and Prometheus, and they will create alerts if one of the nodes are overloaded or underloaded depending on the resources they have. They will call Octopus, which will create a new node on the cloud or destroy one of them. Okay, let's see the components by one. Here you can see the console agents and the applications that are running on them, and here are the nodes with the IP addresses, as you can see. The next one is Prometheus, As you can see in the targets menu, we have at the moment two nodes. One of them is a application node type and the other one is a load balancer node type. If we check first, as you can see in the IP address, our application, this is reachable. This is the IP address of the application node. But if we check it through the load balancer, let's see the IP address, 244, it's ending with 244. You can still reach your application. So it will proxy a request to one of the application nodes automatically. Now what we will have to do to overload our infrastructure is to send a lot of large files to the SQL database, as I mentioned earlier. We just need the IP address of the load balancer, one of the load balancer, and let's start sending a 1 GB large file to the SQL database and a few copies. So it will really overload our application node, which is only one at the moment. If you check in the graphs menu in Prometheus the CPU utilization of the application data new application cluster, you can see that is starting going up. First you can see a peak, which is only because at the moment, at the beginning when the virtual machine is booting, it's running in a high CPU load, but when it's finished the boot process it will go back down. You can also SSH inside the application node and check the CPU load on it. Let's do it. With the top command you will see the resources. Our Java applet, the data avenue application, the Java applet is running at the moment around 40% of CPU, but if you wait a few seconds it will go up to 100. Now it's up to 50, it's now above 60, and go up. In the alerts menu, you will see 4 alerts, both 2 and 2 for the load balancers and the application nodes. When they are not firing, they are green. When they start firing, they are yellow. But first you have to convince, the system had to be convinced that the load remains high or low. So when it remains the same, it will change to red. And when it's red, it will call Octopus to scale. You can see a few parameters and labels of the alert. For example, how much time does it have to wait before it's firing, and a few labels, but all of them are automatically assigned, so you don't have to do anything with them. You can also see the node type and the infrastructure ID. If we check the targets, we see that at the moment we have 1 node, but we will need one more application node. Let's go back to Cloud Signal and wait a few seconds, and as you can see, a new application node type will be started. It needs a few minutes to connect to the cluster. Let's skip it. But as you can see later, it will be connected to the cluster, and in the targets menu you will see that now we have 2 data avenue application nodes, and both of them will run your application. If you check the CPU utilization of the cluster, but let's first make sure that the data transfer are still working and they are not finished. Let's check the CPU utilization, and as you can see it started going down, because now the load is shared between 2 nodes, not just one. We can also log inside the new virtual machine to check the actual load there, as we did in the previous one. This is the IP address of the new node. Let's SSH inside and see the resources. You just have to wait a second and you will see that the Java applet, our application, is running here also with around 90% of CPU. The other node, as we checked earlier, are still running the application, so the two nodes are sharing the incoming file transfers. Okay. As you can see, at the moment the CPU utilization of the cluster is in a perfect position, so the application is running as it is expected and the users don't see any problem at all. As you can see, the overloaded alert is now stopped firing, so everything is fine. Let's stop the file transfers, and as you will see, the load will drop to 0% while no one will use the applications. And yes, this is the case. Of course, in this situation we don't need two virtual machines, so we have to scale down our infrastructure. You can see that first it's firing with yellow, and when it's convinced it will start firing with red color, which means it will call Octopus to scale down. Let's check again the CPU utilization. Yes, it remains around 0% for an amount of time. In our case it was 1 minute, as you would see. We have still two nodes because it's waits. But when it's changed to red, it will scale down. Okay. As you can see in Cloud Sigma, one of the nodes will be destroyed by Octopus. The Alert Manager takes care of the nodes. Alert Manager is summarizing the alerts, and it won't scale 2 times or 3 times, just will scale every 5 minutes, but you can change it if you wish. Now one of the virtual machines is stopped, as you can see, and it will be deleted. Yes, it's deleted. You can see the same in the targets menu in Prometheus. One of the nodes will be down. A few seconds later, when the console notifies Prometheus about the node changes. Okay. Let's check the CPU. Yes, it still remains pretty low. In console you can see that one of the nodes is in orange color, which means it's not reachable. This was the node that was destroyed. But if you check the application, you can see that it's still reachable. Why? Because the load balancer hijab proxy will proxy a request to the remaining application node. If you check the alerts, you can see that it's still firing with underloaded alerts because it's underloaded, but we don't want to scale below 1 node because then our application won't be reachable, so we don't let it to scale. There is always the minimum number of nodes available that you specified in the infrastructure definition, which I showed you in the beginning of this video. Okay, thank you very much for watching.